Alright guys, so hi, I miss your faces. Let's get right to it. This is going to take me a little bit of a while to do, but like I promised, I'm gonna fulfill that promise of going through every single question on your summative review, or not summative, there's no such thing as summative anymore, your assessment review packet. Alright, so number one, let's get right into it. So circle all of the expressions below that are equal to 343. Done. Just kidding. You can't just guess, guys. You have to be able to do it. So clearly it looks like you want to use a base of 7 because we've got a bunch of 7s here, right? So let's do this. We have to break down this number, 343, because I don't know if this is equal to that or not, because I don't know what it is. Actually, I know that that's wrong because it's a negative exponent, and any negative exponent will look like something with a 1 over it. So yeah. So let's break it down. 343, and you're going to use 7 to break it down, right? 343 divided by 7 is 49. You don't have the same number, so you have to keep breaking this 49 down with another 7, and then you're done. 343, if you write it in terms of a base of 7 or a power of 7, is 7 to the third power. Okay? Hopefully you guys are good on that so far. Now let's circle the things that match. This, automatically matches, right? This one right here, I know it's tricky because you have a parentheses, but you have to remember that that is multiplication here. Okay? So you're going to add these exponents. 2 plus 3, which turns into 7 to the 5th power. That's wrong. This one's a little weird. Give me a second on that. Let's multiply this in with the distributive property. 3 times 1 is 3. So that's right. And here, when you have a fraction, you remember you have to subtract them. And you go top down, guys. Don't do 11 minus 8, because that's not top down. That's not the way you read a book. That's not the way you read problems in math. So 8 minus 11 would give you negative 3. So basically this whole thing is going to be 7 to the negative third power. And that's not what we want. Boom! Now let me break this 49 down, because I don't know what it is in terms of having 7 as a base. First off, I'm going to say it's automatically wrong, because 7 is smaller than 49, and this base of 3 is smaller than 7. So I can clearly tell it's automatically wrong, but I'm going to show you how to do it anyways. Let's break this down with 7s, right? So 49 is the same thing as having 2 7s, which is 7 to the second power. Remember, you rewrote this number, 49. So you need to set up your parentheses, and you can't forget about the 7. Sorry, I want to close my blinds. Hold on. Hold on. Okay. Sorry about that. My blinds were being annoying. So, multiply this 7 in. Woo! And then that's going to give us 7 times 2 is 14. That's not what we want at all. So that is wrong. So once again, the only two ones that are right, that are equal, is 7 to the third power, and this one over here. Okay? Hopefully that was pretty straightforward. Moving on! So, you're using this box and only what's in this box to find out what's equal to this guy. Right? Alright, if you want to, clearly you're going to use a base of 10, right? It's all over the place. If you like breaking this down with a 10, you know what I mean, you're more than welcome to do that, but I don't have, oh gosh, what did I do? I don't have time for that. I told you guys you can count the number of zeros. 1, 2, 3, 4, 5, 6. So you're going to rewrite this as 1 over 10 to the 6th power. Remember, if it starts off as a fraction, you're going to end up with this, right? Now, let's move this 10 to the 6th power up. Whee! So that's going to become 10 to the negative 6, okay? Hopefully that was pretty straightforward. I know we've done a lot of examples of that. So for A, you're going to pick negative 6. Remember, you can only use each of the things in here once. Here, it's multiplication. So I know whatever exponents I have, I'm going to add them. So you know what? I probably want for them to be negative. I don't want to use that. I'm not going to use that. I'm not going to use that. That's a little big. I can make that work actually. I'm going to show you in a second. But if I want it to be negative 6, I can use this and this. Bam. Done. 10 to the negative 2 and 10 to the negative 4. You could check if that works because you would add these two exponents because you're multiplying. And that equals negative 6. So this is right. Another way, sorry, I have all these x's. So I just use these. I'm going to block these up. Another way you could have done this was if you use 10 to the negative 11, right? And then 10 to the 5th power. If you do negative 11 plus 5, you also get negative 6. So it works either way. I like what I did first because I feel like it makes more sense, even though that doesn't make sense, but whatever. Alright, so cool. Alright, let's go to this. I know that I need 10 to the something power in here. What can I use that's pretty small? I know I can't multiply anything by 5 to get negative 6. Well, you can, but none of these options. 11 is too big. Let me try this. Let me try that 10 to the 2nd power. What number would I multiply this 2 by to get negative 6? Aha! Bam! Negative 3. Right? Because if you distribute this negative 3 in, negative 3 times 2 would equal negative 6, right? So this does work out also. Let me catch up to what I've done. Cross that out, cross that out. Now, for this, it's going to be, usually if it's going to end up being negative, guys, you put a smaller exponent up here than you do down here. That's kind of what we've been doing if you haven't caught on to that yet. So let's use two positive ones. 10 to the 5th power. And then 10 to the 11th power. And I know I'm flying through this, but this is kind of a review. So hopefully you've already tried this on your own. If you subtract these, right? Because you're dividing. 5 minus 11 equals negative 6. So that works. Alright, hopefully that is cool. Moving on. Bam! Number 3. Laura solves the equation 2 to the x power equals 9 to the 3x plus 1 as follows. That is weird. Well, alright, anyways. So A, what mistakes did Laura make in solving the equation? I don't like that this tells you how many there are, personally, because I know your test isn't going to tell you that. So let's just look at it ourselves. Personally, I don't like right here that they didn't rewrite this 3x plus 1. That's not really a mistake. I guess that was left off for whatever reason, but whatever. Now, it looks like from this 9, they broke this down. 9 divided by 2 equals 7. I don't know what the heck this person was thinking, right? So right there, this is an error. So I'm going to type that up. So Laura made an error in breaking down the 7. She doesn't know what she's doing. Anyways, Okay? So that's definitely an error. We know that, right? Okay, so we've got that down. We've already checked that. Let's move down. I'm on this level now. Okay? So she got 2 to the x, which she brought down. I get that. That makes sense. On the right-hand side, she's got 2 to the 21st power with an x plus 7. I don't know. How did she get a 20? Ah, she did 7 times 3. You can't do that. This is a big number. This is an exponent. You can't do that. That is an error. So another thing I could say that Laura did. Laura multiplied a base of 7 with the exponent. Or the exponent 3x plus 1. You messed up, Laura. Apparently you don't have Mr. Hadler as a teacher. Anyways, hopefully that makes sense. It looks like everything else is okay. Like she set this equal to this, which is here. And then, you know, she kind of solved it. She did minus 21. Yeah, everything else is good. It's just those steps at the beginning that she messed up on. Alright, so now, B. Can you solve the equation 2x equals 9 using what we've learned in class? You guys already know that that is not true. I kind of already went over that today. 2, you can't break that down any further, so that's going to be your base. Right? 9 divided by 2 is 4.5. You automatically see that this does not work out. And if you had to explain as to why, you could say something along the lines of 2 is not a base that can evenly go into 9, right? Now if it was 3 to the x equals 9, this goes into 9. That works. But what we were provided with, this 2x equals 9, does not work. Okay? Moving on to the bottom of the back. Now we have to solve these, right? Sorry, let me check my text message because I'm popular. Never mind. Alright, so this looks weird. I know this looks tough, but as I always say, take a step back and you should be able to do it. 2 is going to be the base of this problem. You can't break that down any further. So we don't want this 2 down here. We want to move it up. But before you do that, please remember that there is a 1 hiding there, right? And if you forget that, how many 2's are there? 1, Mr. Hailu, right? Let's move this up. Bam! This is going to become, or what's inside the parentheses, sorry, is going to become -1. You keep that 4 outside, right? Because we haven't done anything with this yet. Now, you're going to distribute this. 4 times -1 is going to give you -4. And then you just set your exponents equal to one another. Because we have the same base now. -4 equals x. Okay? Hopefully that one made sense. I'm moving on to this one. So, I've got 1 over 25, all that to the x power equals 5 to the x minus 6. 5 is clearly the smaller number. That is what my base is going to be. If you like breaking this down, you could do that. But I really expect you guys at this point in time to know that this is the same thing as 1 over 5 to the second power, right? X equals 5 to the x minus 6. Okay? That's minus 6, by the way. Ugh. Okay. Now we've got to move this 5 to the second power up, right? How do you do that? Move it up, you cross the line, change the sign. That's going to become a -2. Keep that x out there. And I'm just rewriting this thing on the right because I haven't done anything with it yet. Almost done. Distribute this x in. Then we're going to have 5 to the -2x equals 5 to the x minus 6, right? Now that we have the same base, make your exponents equal to one another. Negative 2x equals x minus 6. Okay? Like we always do, guys, I want to get my x's on one side as fast as possible and my numbers on the other. In order to do that, I would move this x over here. Okay? Or how some of you guys say it, which I really like, is you have to take that x away, which would be subtracting an x. Bam! Negative 2x minus an x means it's getting smaller by another x, so you're going to have negative 3x over here equals negative 6. This does not equal negative 1, guys. Be careful. I know some of you guys think that when you look at it. Be careful. Alright? We know that there's multiplication here, so we're going to divide by negative 3 on both sides. Okay? And your answer for this one is x equals 2. Hopefully you got that. Next one. This one's weird because you have to break down both sides. Let's pretend you didn't know that, because I know we've done some problems that look like that. 4 looks smaller, right? So I'm going to break down the bigger number with a 4. 8 divided by 4 is 2. Wait a second. I don't have the same number. So you keep breaking this one down. 2, 2. And since we have a base of 2 going on this right side, I know I'm going to need to break this side down also, right? So I'm going to rewrite this 4 as 2 to the second power. Sorry, let me have some separation between the problems. I'm going to write this 4 as 2 to the second power, which I did, and then I've got x minus 3 outside, because I haven't done anything with that. Equals 1, 2, 3. 8 is 2 to the third power, correct? Good. I'm glad you're responding to me. Are you shaking your head up and down? Yeah, I see you. Not really, because I'm trapped in a computer. I'm just a voice. Alright, you have to distribute this stuff out. Now I'm going to have 2 to the, this first arrow, x times 2 is 2x. You got to keep that minus. 3 times 2 is 6 equals x times 3 is going to be 2 to the 3x, right? Once again, we have the same base, so set your exponents equal to one another because we're solving for the x there. Alright? Okay, I want to move my x's over here, because if I move this over here, I'm going to have nothing left on that side, and that's not what I want to do. I want my x's on one side and my numbers on the other side. So to get rid of this 2x, you would take it away. Minus 2x. Bam. What's left over here? You've got negative 6 equals x. Or 1x. However you like it. Whatever floats your boat. Okay? So, hopefully that made sense, guys. I hope that went well. You guys have been doing really good at this. Now, these two, I expect for there to be a little more difficulty. Okay? Like I stated before, guys, you're more than welcome to set up a table. Do it if you want, if that works for you. Here they're talking about years. The first person they're talking about is what? Oh, they're different rocks. So you could do rock 1. Oh, I can't spell. It's okay. Leave me alone. The second one is rock 2. And then you could do all this work, right? But, which I know you could do. But basically what I want you guys to do is get to the point where we're able to set this up and solve for it, right? Okay. So, at the beginning of the year 2000, geologists discovered a rock whose weight, was estimated to be 1 megaton. So start off with 1. Each year, due to erosion, the mass of the rock decreased by a factor of 1/2. I know they said decreased, But still, a factor of 1/2 means they're multiplying by 1/2. Okay? So this side is going to be 1/2 to the x power. That's that. That's it for the first rock. At the beginning of 2010, see how this was 2000 and this was 2010? I'm going to write, I think it's important to note that 10 years, oh my gosh, this is ugly. 10 years passed, okay, between them finding this first rock and the second rock. That's important. Anyways, second rock was found whose mass was also estimated to be 1 megaton. The rocks are twins. Each year, again due to erosion, the mass of the rock decreased by a factor of 1/4. So this one is going to be 1/4 to the x. And you remember how 10 years passed? Minus 10. Okay? And then guys, now what you do is you just solve this guy for x. Okay? You want to make this a 2 over here because clearly that's going to be our base for this problem. I'm going to kind of do both sides at the same time, so please try to follow along. This is 2 to the first power. So I'm going to move that up. And this side is going to become 2 to the negative 1 with an x. Okay? This side here, just because I don't have a lot of room, I'm going to erase this 4. Because I know that you guys know that 4 is 2 to the second power. You could break that down. I also want to move this up. Okay? And that is going to become 2 to the negative 2. And it's going to have an x minus 10. Okay? And now it looks very familiar at this point. We are just going to destroy this. Negative 1 times x is going to be negative 1x, or negative x. This first one, x times negative 2, is going to give you negative 2x minus 10 times negative 2 is negative 20. Subtracting a negative just becomes adding, by the way, in case you didn't know. Alright, let's move this over here because I'm running out of room. Now that my bases are the same, set the exponents equal to one another. Okay? So negative 1x equals negative 2x plus 20. I want to move this over here. So I'm going to add 2x, add 2x, okay? And then over here, negative 1x plus 2x equals 1x, which equals 20. And 1x is really 1 times x, which is x. You're done. The answer is 20. Okay? Whew! That was a lot of work. Did you work as hard as I did? I hope you did. Alright, next. The town of El Dorado was founded in 1680 with a population of 100. Every decade, so every 10 years, the population of El Dorado doubled. The town of Las Cruces was founded 80 years later. Wait, okay. In 1760, with a population of 100. Every decade, the population of Las Cruces multiplied by 4. In what year were the populations of the two cities the same? Man, this is tough. Alright, let's do it. Let's see. Honestly, I didn't practice this before doing the problem, so wish me luck. Alright, so I see that it says every decade. I think that's kind of important. Because here they said the town of Las Cruces was founded 80 years later. If each decade is 10 years, the town of Las Cruces will be, I'm going to write this note here, 8 decades later, right? It's not Yeah, anyways. So 8 decades later. With the population of 100. So, did they tell us? Oh, I missed this word completely. The population of El Dorado is doubling. Okay? Let's see, El Dorado was 2 to the x power. You know what, guys? Hold on. Okay, so I'm back. I'm not gonna lie. I paused the videotape and I thought about this problem very hard, and I realized I don't like it, and I'm sorry that you have it. So what I'm gonna do is I'm gonna show you the way that I think this problem should have been written and how to solve it based on that. And then also, just for those overachievers, I'll show you this more difficult way to do it, okay? I guess. Okay, anyways, first off, these populations of 100, I want to take that away because that's not what we worked with. We have always started with 1. So I'm going to do that for both towns. Okay? Anyway, so El Dorado was doubling, so that's 2 to the x power, right? Now, Las Cruces, which is the other town, was founded, and every decade the population multiplied by 4. So for Las Cruces, it's going to be 4 to the x power. But wait, they started 80 years later, which I already took a note on, is 8 decades later, because that's how they're measuring time. It even told us in this problem, okay? So you're going to do -8, okay? Hopefully you guys are following this. So I'm going to bring this 2 to the x power down. I'm going to rewrite this 4 as 2 to the 2nd power, right? Bam, bam. X minus 8. Distribute that in. Over here you're going to have 2 to the x equals 2 times x is 2x minus 8 times 2 is 16. Okay? We have the same base. So I'm going to say x equals 2x minus 16. I just set my exponents equal to one another. And now I want to get this over here. I'm going to take this 2x away, which is subtraction. Bam. X minus 2x gives you negative x, or negative 1x, which equals negative 16. And then let's divide by negative 1 on both sides. Okay? And that's going to give you an answer of x equals 16. Okay? So that kind of concludes how to do these problems, guys. I am going to go a little deeper and show you how to at least set up the equation. If it was a population of 100, you're not going to need to know this for your assessment, but just to show you why I did that, I'll erase all of this. Okay? Hold on. I have a phone call. Alright, so basically what I was trying to say was, if you start off with a population of 100, guys, I don't like the way it was set up, to be completely honest, because if 0 weeks had passed, right, you do 2 to the 0 power. This one doesn't even make sense. You can't have that many people, because this would be 4 to the negative 8. And then you can't have like negative people. It's dumb. Anyways, so this would be 1 person after 0 decades. Sorry, I said weeks earlier. Decades. But it tells you right here, it starts off with a population of 100. So once again, this is not going to be on the test. I am just pushing the envelope here. Okay? So to set up an equation for this, you would just have to write times 100. For each of these as a separate number, as a separate base. So now if I was to say if 0 weeks passed by. 2 to the 0 power is 1 times 100 is 100, and that would match this. But like I said, forget all that. You don't really need to know it. That's kind of pushing the envelope, and I just wanted to justify as to why I did something different. If you guys study this like the back of your hand, you are going to be golden for this assessment. You know, you can comment if you have any questions on this video. You can see me during lunch. Whatever, you know, just let me know. Email me, blah, 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 blah. Work hard. Please study, guys, and not just the 5 minutes before the assessment. Please study, and I know you guys will do great. You have been working very hard, okay? So keep up the great work, guys. I can't wait to see how you do on this assessment, okay? Take care and have a good night. Bye.